Hello, good evening. My name is Joanna Earthlight, and today we will be talking about the structure of an atom. Some people say the atomic structure, but I like to call it the structure of an atom or atom. Now, we'll be using the Niels Bohr's model, which is kind of like the model of the solar system that has the sun in the center and the planets orbiting around. Well, Niels Bohr designed a model with the nucleus in the center and the electrons orbiting around the nucleus. Now, the atom has three subatomic particles. I like to call them PEN, P-E-N. P for proton, E for electron, and N for newtons. P for protons, E for electrons, and N for neutrons. And those are our three subatomic particles. They're found in all atoms. Okay, so let's see. The first two, which is the proton and the neutrons, they are found in the nucleus of the atom. Then we have the electrons, which are found outside on those circles or rings called energy levels or shells. Right. Yes. So that's the nucleus. So we have the shell or energy level. That's where you find the electrons, and then you have the protons and neutrons in the nucleus of the atom. Now we have the periodic table of elements, which is going to help us to find each subatomic particle. We have here aluminum with the atomic number of 13. We have the symbol, and we also have the name. And at the bottom, we have the mass number, or the average atomic mass. And look, these are how all the elements are represented on the periodic table. So we have an atomic number there at the top, the symbol, and at the bottom there, we have the mass number. So each element is represented in that way. Now there are some rules that we have to remember when we are looking at the periodic table and we want to do the structure. We have to remember the P is proton, E is electron, and the N is neutron. We also have to remember that the number of protons is always equal to the number of electrons, which is equal to the atomic number. So the proton, electron, and the atomic number is actually telling you the same thing. It's the same number. So in order to find out the number of neutrons, however, we have to do a bit of calculation. We have to use the 2 number. So we have to subtract the atomic number from the mass number. And that will give us the number of neutrons in the nucleus of the atom. So let's apply that to some of our elements here. And remember that elements are made up of atoms. So we have the hydrogen atom, 1 for the atomic number, 1.008 for the mass number, or the atomic mass. Now, we still remember we have to use our PEN method, P for protons, E for electrons, and N for neutrons. We're trying to figure out how many protons, electrons, and neutrons should go in the hydrogen atom. Now we know the atomic number is 1, so therefore the number of protons will equal to 1 and the number of electrons will be equal to 1. And we write those in our nucleus, 1 proton. And we don't know how many neutrons yet, so we have to calculate. We know that 1 is the mass number, 1.008, rounded off to give you 1. Then we subtract the atomic number of 1, give us 0. So we have no neutrons in the nucleus of the hydrogen atom, and we have 1 proton. Now our electrons that goes on our shell, we only have 1, so we just put 1 electron on that first shell. And the first shell is the one closest to the nucleus. We just represent that as 1. Okay, let's look at our helium atom. It has an atomic number of 2 and a mass number of 4.003. Now we're going to use our pen method, protons, electrons, and neutrons. Figure out how much of each. Now we know that there are 2 for the atomic number. We know that the atomic number is 2. Oh, before we do that, let's talk about these shells. Each shell has a particular amount that we need to remember. The first shell has a maximum of 2. The second shell can hold a maximum of 8. The third shell can hold a maximum of 18. And the fourth shell can hold a maximum of 32 electrons. It's kind of complicated when it gets to the third and fourth, but we'll look at that in another video. So let's get back to our helium atom. The number of protons here and electrons is equal to the atomic number. The atomic number is 2, so protons and electrons are going to be equal to 2. Now to figure out the number of neutrons, we have to subtract it. We have to subtract the atomic number from the mass number, and the mass number is 4. Atomic number is 2, so we're going to have an answer of 2. Now let us represent this the Niels Bohr's way. In the nucleus we have 2 protons, we have 2 neutrons, and on our shell we have 2 electrons. 1, 2 electrons. And we represent this just by writing 2 because we have two electrons on the first shell. That's for helium atom. Now let's look at lithium. Lithium is the third element, and the atomic number is 3 and the mass number is 6.94. And rounding off 6.94, we know that is 7. So let's do our pen method. Proton is 3, electron is 3, and our number of neutrons we have to calculate. So we have to subtract our atomic number, which is 3, from our mass number, when rounded off, is 7. And we subtract that, and we should get an answer of 4. 3 from 7 is 4. So therefore, our number of neutrons will be equal to 4. So we have 3 protons, 3 electrons, and 4 neutrons. let us represent that in the Niels Bohr's way. We will have our nucleus. Number of proton is equal to 3. Number of neutron is equal to 4. And our first shell will hold a maximum of 2 electrons. And then we need to put another shell to put the remainder, which is 1 electron. There we go. We have just 1 electron on the second shell. And then we will just simply represent this as 2 for the first shell and 1 for the second shell. 2, 1. And that is our lithium atom. Now let's move on to another atom. Let's do beryllium. Be is the symbol. The atomic number is 4 and the mass number is 9.01. We round that off to a 9. Our pen is proton, electrons, and neutrons. So the number of proton and electron would be 4, seen as how the atomic number is 4. And we just subtract the 4 from the 9, and we're going to be left with 5. So therefore our number of neutron will be 5. Now let's represent it with our Niels Bohr's model. Our nucleus here has 4 protons and 5 neutrons. And we have 4 electrons, since we know that it's the same as the protons. And remember, 2 could go on the first shell, and we need a maximum of 4. So we have to draw the second shell and put 2. So we have 2 on the first shell, 2 on the second shell. We represent that as 2, 2. And that is it for our beryllium atom structure. Next, let's look at another one that's bigger. Let's look at aluminum. Aluminum has the symbol Al. It has an atomic number of 13, and it has a mass number of 26.98. And when we round that off, it would be 27. Now let's write our pen method: proton, electron, and neutron. Our proton is equal to 13, seen as how the atomic number is 13. And our electron will also be equal to 13, seen as our proton and atomic number is 13. But then we have to calculate to find our neutrons. So we have to subtract the atomic number, which is 13, from the mass number, which is rounded off to give us 27. So 27 subtract 13 will give us an answer of 14. Therefore, the number of neutrons in this aluminum atom is 14. And let's represent that. So we have our nucleus here, 13 protons in the nucleus, 14 neutrons in the nucleus. Our first shell can hold a maximum of 2. Second shell can hold a maximum of 8. Perfect. Let's fix that. Okay. So we go 1, 2, 3, 4, 5, 6, 7, 8. And then we have 2 plus 8, that's 10. but we want 13. So we would have to draw our third shell to put our remaining atoms. We know that's already 2, 8. We need some space there, so let's erase that and draw, put our remaining 3 atoms. So that is 2 on the first shell, 8 on the second shell to make it 10, and then we have 3 on the third shell to make it 2, 8, 3. That's 13 electrons in total. And that's it for aluminum atoms. Thank you for watching my video. Like and subscribe.